In this video, we are going to go through the notes and examples for section 1.6. 1.6, there's not a lot of new math type problems to solve. They're actually going to be pretty similar to what we saw in 1.5 with different angle measures and finding those measures based on the idea of the whole and how two parts add up to equal the whole. It's mostly new vocabulary. So as you're going through 1.6, be very conscious of the vocabulary words. Use these words often. If you see a word and you don't remember what it means, go back and look at these notes for your definitions. Our first word here is adjacent. Adjacent. In normal language, adjacent generally means like next to. And it's similar in geometry, but we need to be a little bit more specific. So adjacent angles are two angles that share a common side and vertex, but have no common interior points. So here is an example of adjacent angles. So angles 5 and angle 6 are adjacent. Notice angle 5 is here, angle 6 is here, and they have the same vertex. Both angles have the same vertex, and they also share this side. But there are no points inside either of these angles that are the same. So that's an important distinction. So angle 5, if we were going to write this using proper notation, angle 5 and angle 6 are adjacent. And now if we look over at 7 and 8, if you just think about the normal definition of that word, you might think that these are also adjacent. They're not. They're next to each other, but notice they don't have a common vertex. They don't share a side. And when angles are not adjacent, we say that angle 7 and angle 8 are non-adjacent. So any two angles can either be classified as adjacent or non-adjacent, always. Moving on, blank angles are two positive angles whose measures have a sum of 90. Remember, this word sum always means like addition, so two angles added together equal 90. The word for that is complementary. So complementary angles add up to 90 degrees. And we might say that one angle is the complement of another, and that means that the one angle plus the other one we're talking about add up to 90. So complement or complementary. Similarly, supplementary angles add up to 180 degrees. I'll just fix my y here. Supplementary angles are two positive angles whose measures have a sum of 180 degrees. We saw a lot of this in our last section. Angles that add up to make a straight line are supplementary. So this is an option to pause real quick, look at these 4 different diagrams, 1, 2, 3, 4, and ask yourself, are the angle pairs shown complementary, supplementary, or neither? So number 1, angles 1 and 2. Angles 1 and 2 clearly add up to 90 degrees. We have the box in the corner. That tells me that the whole angle is 90. So angles 1 and 2 are complementary. Second image, angles A and B, they add up to 90, but this can cause some confusion because they're not connected. They're not adjacent angles. They are still complementary. Okay, complementary is any two angles that add up to 90, whether they are adjacent or not. So 1 and 2, we would say, are adjacent and complementary. Angles A and B are complementary but non-adjacent. Similarly, we have the same kind of situation here in the next two diagrams. They are both supplementary. Remember, if they add together to make a straight line, like angles 3 and 4, when you put those two angles together, this is angle 3, angle 4, add them up, they equal a straight line. That is 180 degrees. That is supplementary. Same with this other pair over here, right? 115 and 65. non-adjacent, but they are still supplementary. So this is an opportunity to try for yourself. So choose, name the appropriate angle pairs using proper notation. So pause and try this by yourself, and then check back. There's only one pair of adjacent angles in this diagram, and that's right here, angles BAC and angles DAC. So angle BAC and angle DAC are adjacent. Complementary adds up to 90 degrees, 37 plus 53. So angle BAC and angle RST are complementary angles. Supplementary, if we had 127 plus 53, that adds up to 180. So angles CAD, not B, CAD, and angle S. Remember, I can call this whole thing just angle S because that's the only angle that has this vertex, right? So I can call it S and save myself a little bit of writing. Over here, though, if I said angle A, that could mean either of these. So I can't say angle A. I have to use the 3-point naming method there. Moving on. Two adjacent angles are a linear pair when their non-common sides are opposite rays. The angles in a linear pair are supplementary angles. A lot of different connections going on. Linear pair, so linear means line, pair means two. So two angles, 1 and 2, that make a straight line. We call them a linear pair. And of course, if they make a straight line, they are also supplementary angles. So a lot of different vocabulary tied together there. Next, two angles are called vertical angles. Vertical just like straight up and down. Vertical angles when their sides form two pairs of opposite rays. So for examples, angle 4, if I think about this angle being two rays, angle 4 and angle 5, okay, so then we would have a pair of opposite rays here and a pair of opposite rays here. Angles 4 and 5 are vertical angles. The way I always think about this is you have to make an X. So if you have two lines making an X, then those angles that are formed opposite of each other are vertical. So for example, angle 4 and angle 5, and then we have the other pair, angle 3 and angle 6. These are both pairs of vertical angles. And this, you might want to pause this and kind of digest this for a second. There's one more really important thing about vertical angles, which I want to tell you now because I think it'll help you understanding, but we're not going to do a lot with it math-wise until a little bit later. But they're always going to be congruent. So 4 and 5, pair of vertical angles, they are always congruent. So vertical angles are congruent. So later on, when you're trying to determine if a pair is vertical, if they don't look like they're the same size, then you're probably making a little mistake somewhere. Okay, so number 2, again, this is a try it on your own. Look for any pairs of vertical angles in the diagram here to the right, and any linear pairs. So pause and try that on your own. Okay, the pair of vertical angles, there is only one in this diagram. Students make a lot of mistakes here. Remember, we're looking for the X. So this is where we have our X, and then the pair that are across from each other are angles 1 and angles 5. Angle 1 and angle 5. Any of the other pairs, if you look and you try it, they don't make an X, like people might think 2 and 4. Right, so if we look at angle 2 and 4, they don't, we can't make the X to get those angles. Angle 4 is a lot bigger than angle 2, right? Vertical angles are also congruent. They can't be. We do have two linear pairs in this diagram. Remember, two angles that together make a straight line. So here's a straight line where angle 4 and angle 5 make a straight line, and then the other pair is here with angle 1 and angle 4. So angle 1 and angle 4 are a linear pair, and then angle 4 and angle 5 are another linear pair. Like I said before, the problems that we solve in this section are going to be very similar to what we've done in the previous section. We're just going to use some of that new vocabulary. So kind of our real-world example here, when viewed from the side, the frame of a ball return net forms a pair of supplementary angles with the ground. So that means that these two angles are supplementary. They add up to 180 degrees. We could also call this a linear pair, right? Because the two together make a linear pair. So I would definitely try this one on your own and then come back. I'm going to go through the solution pretty quickly because this should be review. The equation we would set up, 5x plus 10 is our first angle, plus 3x plus 2, our second angle, has to total 180. We combine like terms, we get 8x plus 12 equals 180. Subtract 12 from both sides, you'll get 8x equals 168. And then divide both sides by 8. 168 divided by 8 is 21. X equals 21. And then if we plug that back in for x in both of our spaces over here, so this would be 3 times 21. Let me get this out of the way here. Maybe 3 times 21 plus 2. 3 times 21 is 63, plus 2 is 65 degrees. And then you could plug into the other one here. You could plug in for x. So 5 times 21 plus 10, or we just know since they have to add up to 180 that this would have to be 115. So a good way to check your work would be to plug in 21 for this x in angle BCE and just double check that you get the same answer.